Okay, we will start without wasting any time. How many people? 27 have joined. Okay, they will join in few minutes. We will start with the today's topic. Okay, we will start with today's topic. Am I audible?
Yes, sir.
Okay, ठीक है. Okay, all of you are requested to mute your mics and mobile phones. Okay, just on ठेवा speaker. Okay, we will start. Hmm. So already we have started chapter number 2, which is energy storage and distribution. In that chapter we have seen electric energy route, okay, starting from the generation to distribution. Okay, after that we have seen the different load curves for electric energy consumption, which includes base load and peak load. Okay, then we have seen the description about the different loads. Uske baad we have seen the power plants which are going to supply the base load and peak load and intermediate power plant intermediate loads. After that I have given this point to you for the homework, okay, which consists of the comparison between base load and peak load. And then we have seen the intermediate load and the uh, comparison or the graph for all the loads and the power plants which are supplying the load. So now today we are going to see the last point of the chapter, that is energy storage plants. So as the name indicate, energy storage plants are the power plants or operating plants which store electric energy for the uh, importance when there is loss of power or the sufficient amount of electricity is not being produced by the other plants at that time, or for in case of convenience, energy storage plants are used, okay, to replace the conventional power plants. So as we know that due to growing concerns about the environmental impacts of fossil fuel and the capacity and resilience of energy grids around the world, then engineers and different policymakers, they are turning their attention to energy storage solutions because of that thing. Also, energy storage can address the intermittency of solar and wind power plant. Now here in this case, intermittency is the word which refers to the reliability of continuous supply of power. If the solar power plant and wind power plant fails for some reason to produce the electric power because of the what you call it as weather conditions, which includes the rainy season, in that season solar or the sunlight is not that available. And also in case of wind is not already available for 24 hours. It is maximum at some time and minimum at some time. So because of the intermittency of the solar and power plant, wind power plant, energy storage plants are evolved. Also it can also increase the response rapidly to large fluctuations in demand. Suppose at the time of period from for a peak demand starting from 6 p.m. to 9 p.m. in the evening, suppose there is a large fluctuation of demand in kilowatt for the electric energy. This energy storage plants can supply or can fulfill the demand. It will make the grid more responsive and it will reduce the need to build backup power. Now here in this case, the grid is a word which is the interconnection of different power plants in order to supply and to maintain the reliability of electric energy throughout the day. Also, in many cases, the effectiveness of energy storage facility is determined by how quickly it can react to the changes in demand or the maximum demand. So now the rate of energy lost in the storage process and its overall energy storage capacity, also how quickly it can be recharged. So these are the points or factors on which the effectiveness of energy storage plants can be described. Now energy storage is not a new concept, okay, right now it has been developed since the year 1800s, okay. And also the pumped storage hydropower plant has been operating in the United States since the year 1920s. So pumped storage hydropower plant is an example of energy storage plant. But as we all know that the demand for a more dynamic and cleaner grid has led to a significant increase in the construction of new energy storage projects. Okay, and also to the development of new or even better energy storage solutions. So fossil fuels, as we know, are the most used form of energy right now. Okay, partly due to their transportability and also the practicality of their stored form. Okay, that can be stored in a easy way than the other supplies or the other energy producing materials. Now this advantage of fossil fuel will allow to generators, okay, to generate considerable control over the rate of energy which is being supplied to the consumer. Also, which states that the energy generated by solar and wind power plant is intermittent and reliant, which means that it depends on weather conditions, okay, and the climatic conditions. Also, renewable has become increasingly prominent on electric grid, and there has been a growing interest in systems that can store clean energy. So such advantages will lead us to make the use of energy storage plants, even if there are different renewable energy storages and fossil fuel storages. Also, as extreme weather will be there in some cases or some days or some months, and there will be some climatic change conditions, okay, and because of this such things, when the power plants will not be able to give or reliable energy output at the consumer end, at that time we can use energy storage plants. So these are the needs of why energy storage plants are required. Also, here energy storage plants will contribute for meeting the electricity demand during peak times. As I said earlier, if a peak of energy demand is increased at some time of interval, at that time you can use energy storage plant to supply the peak times. Okay, for example, on summer days when AC or air conditioners are blasting, or at nightfall when households turn on their lights and electronics. So these are the examples when the possibility of peak can happen. Now we all know that at the time of peak period, okay, peak time or peak period, the electricity as the demand is increasing, so the power plants which are supplying the peak time will have to work more than the other days or other time of the day. So that means that electricity becomes more expensive at that time of the peak, because the power plants has to ramp up production or increase their productivity and efficiency in order to accommodate the increased energy uses. Now here in this case, the energy storage plants that we are going to use will allow greater grid flexibility, okay, which means that we can connect the energy storage plants to a particular grid which contains a lot of different uh, power plants, including renewable and also non-renewable energy sources, and it will give a greater grid flexibility as distributors, okay, like MSCDCL, MSCB, etc., can buy electricity during off peak times. Off peak times mean when the demand is constant or low, and at this time the energy is quite cheaper, okay, and sell it to the grid when it is in high demand. Okay, so energy storage plants can be useful for this concept or this particular time. So the relevant example of this off peak or cheap energy is the happy hours that we are going to that we are seeing in the Starbucks or different cafes. At the time of happy hours, they are giving more discounts than the main peak hours or even the Ola and Uber companies, they are surcharging their prices at the time of peak demand. Okay, that is the same example of this energy buying and selling, buying at of peak time and selling when it is in the greater demand. Now also energy storage provide resilience since it can serve as a backup energy supply when power plant generation is interrupted. Suppose there is a power plant which is of coal, okay, coal power plant, thermal power plant, even hydro power plant. Suppose there is some technical difficulty or technicality and due to which the power plants shut off, and that time we can use the energy storage to supply the grid so that the electricity at the consumer will not going to be interrupted. Okay, so this is the need of why the energy storage plants are used in the country or in the other countries also. So now this table shows the distribution of different energy power plants. Like there are different examples of energy power plant. Okay, first one is hydro pumped, or we will see it in the next slides, pumped hydro power plant. Okay, this is a secondary part of hydropower plant. Okay, then compressed air, then molten salt which is thermal, then lithium ion battery, lead acid battery, flow battery, hydrogen and flywheel. So these are different energy storage plants. It also, this table also provides us the maximum power rating. Okay, so pumped hydropower plant has a power rating of 3000 megawatt. It will it is having a discharge time from 4 hours to 16 hours. Okay, and it has, you can see here, life cycle from maximum cycles or lifetime. So lifetime age of that particular plant they have shown here, then energy density they have shown, and efficiency they have shown. Okay, so there are different. So pumped hydropower plant having efficiency 85% because it is very simple to construct and simple to operate. Okay, and the energy or the raw material is water which is freely available, so we can use it in a easy manner than the other uh, what you called as different power plants which requires different raw materials for the energy production. So in case of compressed air, efficiency is varying from 40 to 70. It has quite less efficiency because the maximum life cycle is also less and discharge timing also more. Then thermal power thermal energy storage plants, then lithium ion battery, it has the we can see here in this case it has the highest efficiency because its lifetime is very high, because we just need to maintain the battery conditions and then we can use the battery for long years. And also, but the rating, power rating is very less in case of lithium ion battery. Also in case of lead acid battery, power rating is less but the efficiency is high. Now this efficiency is respected with respect to the power rating. Okay, as one second, notification is there. Okay, ठीक है. Hmm. We will resume. Hmm. So lead acid battery, where I was telling the efficiency is related to the maximum power rating. Now in this case, this lithium ion, lead acid battery, flow battery, hydrogen storage power plants, they will supply maximum power rating of 100 megawatt only. So for this amount of energy, efficiency is 85 to 95%. When they are going to supply this much of energy, which is not possible right now, the efficiency will be comparatively less. Okay, so pumped hydro power plant is the very popular energy storage plants in case of India also and US also. Then flow battery, then hydrogen we are going to use. Okay, there is a lot of efforts that has been done by the government to convert from gray hydrogen to green hydrogen. Okay, you can see here it also supplies very less power rating, 100 megawatt only. Efficiency is also very less, but it can be useful as a energy storage plant. And flywheel. Okay, now we are going to have a look on what are the different things. Now here, if you can see the flywheel has only discharge time in minutes or seconds. Okay, because It is a kind of capacitive plant which supplies the power. You can see here, if possible, efficiency is very high right now, but the maximum power rating is very less. This flywheel type of energy storage plant can supply a large amount of power for a very short period of time. Okay, as we can see here, pumped hydro power plant can supply a large amount of power for very large period of time. From 4 hour to 16 hour it can run. But in case of flywheel, it will be turned on for a few seconds or for few minutes or even for few 10 to 15 minutes. Okay, but at that time it can supply up to 20 megawatt. So it is also useful when there is a peak in the, or there is a surge in the peak period. Okay, so now next we are going to have a look on each of the plants one by one. So first of all, we are going to have a look on pumped hydro power plant. Okay, so this is the first energy storage plant, that is pumped hydro power plants. So now before going to the pumped hydro power plant storage, we need to see or have a look on the working of hydropower plant. Okay, I assume that you have very less information about the working of hydropower plant. So we will see how it works. Okay, just from the layout. Okay, so this is a layout of hydroelectric power plant. Okay, we know that in case of hydroelectric power plant, water is used as a raw material. Okay, raw material or a medium in order to convert the kinetic motion into electric energy. So we are using the gravitational power, okay, kinetic energy of the water by using the gravitational power. So in this case of hydroelectric power plant, the plants need to be located at a hilly area where there is a where we can climb, okay, where there is a need for climbing. Okay, so that the gravitational force becomes more, and because of the more gravitational force, kinetic energy will also be more, and because of that, okay, we can generate more amount of power. So here, for the hydroelectric power plant, we need to construct a dam, okay, or a reservoir. So dam is constructed by the use of bricks and stones, and then there we need to store the water. So basically we need to choose an area where there is a high rainfall, like Koina, Mahabaleshwar, etc., and we have to store the water from the rain directly as a reservoir for the dam, and then we have to extract the water, okay, through the pipe, extract the water through the pipe from reservoir to the water turbine. Okay, so now we have to construct a penstock. If you can see here, this penstock is nothing but, this is called as a this is a pipe, okay, which is made up of galvanized iron or galvanized steel, okay, which is having high tensile strength and very high uh, mechanical properties. So the water will flow from a very high height, okay, high level, from this penstock. Okay, it will travel to the, one second, sorry, it will travel from the reservoir to the steam turbine. Now here if you can see, this is a hydraulic turbine, okay, or water turbine you can call it as. So these are the different valves. Now here the gate is used in order to control the pressure. Also here there is a valve which will control the pressure of the outcoming water. There are different rooms, okay. For example, this is the main thing, primary, okay. इसके बाद turbine is connected with the penstock. So as the jet of water strikes to the turbine will rotate, the blades of the turbine will rotate, okay, according to the kinetic energy, and it is connected to the generator or alternator. So as it is coupled with the generator and alternator, it will directly convert the mechanical energy into electrical energy with the help of Faraday's law of electromagnetic induction. Okay, this is the principle, and then it is connected to the transformer, it will step up, and so on, so on. This is the basic hydroelectric power plant. Okay, now what is pumped storage power plant in this case? Now if you can see here, you can see tail water level. Okay, tail water level is nothing but we are going to store the water which is coming out from the this turbine. Okay, I'll show you the diagram for this in the PPT. So pumped storage power plant here, if you can see, this is the this part of upper reservoir is nothing but the tail race or the part which is being stored from the turbine. Okay, water from the turbine, we are going to create another reservoir, and then we are going to use a small hydroelectric power plant, okay, which consists of the turbines and generator. Okay, and then the penstock is inside the crust of the earth that at that time, and here we are going to use this pumped storage hydro power plant for both the purposes. Okay, here first of all we are going to use this water in the upper reservoir for the generating purpose, generation of electricity, okay, by the help of gravitational force. And secondly, the water which is available at the lower reservoir, which has been collected after the turbine, okay, so this can also be pumped back to the upper reservoir. So this cycle continues, and this is why we can call it as a energy storage power plant. Okay, so amount of water is very less as compared to the general power plant. Okay, as compared to Koyna and Radhanagri power plant ka reservoir, this reservoir has very less capacity, so that the water can be pumped easily from lower to higher level. So this can be used for generating the electricity as well as the pumping of the water from lower to higher. As the cycle repeats, we can use this this pumped storage hydropower plant for supplying the peak period or the spike in a peak period. Now these are large scale energy storage plants that use gravitational force to generate electricity. Okay, principle of hydroelectric power plant. As we can see here, the water is pumped to a higher elevation, okay, from lower to higher elevation for storage during low cost energy periods, okay, during off peak period and high renewable energy generation periods. Okay, now when electricity is required, the water is released back to the pool. Okay, for example, we will see here, when electricity is needed, water is released back to the lower pool, okay, generating power through turbines. So when there is a demand in the peak period or some period of time, then the water from the upper reservoir, okay, the valve here is kept open, and the water will flow from high level to low level, and it will generate the electricity because it is coupled with the turbine and alternator. Okay, so we can get the power, and as soon as we can collect the water here, then we need to again uh, pull up the water from lower reservoir to upper reservoir by the help of a water pump, and then we can use the energy again. Okay, we can produce electricity again and again. Now here in this case of energy hydro pumped hydro storage power plants, in comparison to the other forms, this pumped storage power plant can be cheaper, okay, especially for very large capacity storage. According to Electric Power Research Institute, okay, in the US, the installed cost for pumped storage power plant, it will be vary from $1,700 to $5,100 per kilowatt, which is as compared to very high cost of lithium ion batteries. So this pumped storage power plant is more than 80% energy efficient through a full cycle of life. Okay, and it can typically provide 10 hours of electricity, so the discharge time is very high. Okay, 0 to 10 hours compared to about 6 hours for the lithium ion batteries. Okay, now despite of these advantages of this pumped storage power plant, there are long term investments. Okay, it requires very long term investments Permitting the construction can take up to 3 to 5 years. So to construct this power plant, it may take a lot of time as compared to the battery backup power plants. Now here this disadvantage will scare the investors, okay, for a long term investment. So that is the only disadvantage of this, but as compared to the efficiency and the discharge time, it is very good. Okay, this was about the energy storage power plant, which is pumped hydro power plant. Next we are going to have a look on compressed air storage. Okay, compressed air energy storage. This is the second part. We will see with the diagram here only. Okay, now with the compressed air storage, the air is pumped into an underground hole. Okay, we can see here, it is, this hole is under the earth's crust. Okay, so you can see here there are different layers of rock. Okay, and there is a layer of salt basin in the earth's crust before the center of the earth. At the at this location we are going to store the compressed air. Okay, mostly it is called as salt cava. Okay, salt cavern. So during off peak hours, when electricity is very cheaper, at that time we can store the air inside this cavern. But when energy is required, as soon as there is a spike in the peak period, the air from the underground, okay, this cave, is released back into the facility. Okay, where there is containment of different equipments. So where the now in the one second, now the air which is stored in the underground has been compressed into a high pressure. Then it will be passed from this underground cave to the compressor. Okay, first of all, then in this case, first of all, the air has to be exhausted, or air has to be extracted from the atmospheric air through the compressor. And in the second case, so now the compressor can be used when there is a off peak period, and the expander can be used when there is a peak period. Okay, there is a spike. So now in this case, when there is energy requirement, the air is heated and the resulting expansion turns an electricity generator. Okay, now in case of expander, the air is heated, okay, and it converts the heat energy, like we can use steam turbine here, and we can generate the electricity because of the heat. Now this heating process usually uses natural gas, okay, which releases carbon. Now the air, we can also use natural gas here. In case of expander also we can store the natural gas, but preferably air is stored, okay, than the natural gas. But the expander uses natural gas for the burning. But however, this power plant triples the energy output of facilities using natural gas alone. Now this power plant can achieve up to 70% energy efficiency when the heat from the air pressure is retained. Okay, otherwise the efficiency will be between 42 to 55% only. Currently, in case of India, there is no power plant such here right now, but in US there are two facilities. Okay, one is in Alabama and one is in Macintosh. Okay, in the Germany also, in US also. So it, the capacity of that particular plant is 110 megawatt. Okay, and other is 317 megawatt. Okay, so this is a secondary part, okay, of energy storage plant. First one is pumped storage, second one is compressed air energy storage. One second, the notification. Okay, ठीक है. Hello, anything wrong?
No, sir, continue.
Okay, ठीक है, I will continue. Okay. So we have seen pumped storage, compressed air energy storage. Now we are going to have a look on thermal energy storage. Okay, so thermal energy storage facilities use the temperature to store energy. Okay, as the name indicates. So when energy needs to be stored, Okay, then we can use salt, rock and water or the other materials that can be heated and kept in insulated environments. Okay, so when the energy needs to be generated at the peak period, the thermal energy is released by pumping cold water in onto the hot rocks or salt or okay in order to produce steam, which spins the turbine, what is called as steam turbine. Now this thermal energy can be used to heat and cool the buildings instead of generating electricity. That is a secondary purpose. For example, thermal storage can be used to make ice overnight to cool a building during a day. Thermal efficiency can range from 50% to 90% depending on the type of thermal energy used. Okay, either cooling or heating. So this is a very less used energy storage power plant, but it can be used for the buildings, okay, instead of generating electricity. Moreover, next is the most important, that is lithium ion batteries, which we can easily rely for the energy storage. Now here, the first of all, the first battery that has been produced by the company Sony in the early 1990s. Okay, so lithium ion batteries were originally used primarily for the uh, items such as cell phones and walkmans, etc. Okay, for that purpose batteries has been used, which consist of lithium ion batteries. Okay, lithium ion batteries, not cadmium nickel batteries, which can be used in AAA, AA and AA cells. Okay, so this is very different. Now here, recently this lithium ion batteries has seen a lot of different developments in case of EV sector, also in other inverter sector also. They are used for large scale battery storage and electric vehicles. Okay, at the end of 2017, the cost of a lithium ion battery pack for EV, okay, it has fallen. Okay, earlier it was very high, but at the time of 2017 end, it has been fallen to, you can see here, 209 kilowatt hour. Okay, $209 per kilowatt hour. Okay, also it will what you call it as decrease in the next upcoming years up to 100 kilowatt hour. Okay, $100 per kilowatt hour. Okay, with a life cycle of 10 to 15 years. Okay, so if you purchase a battery of lithium ion, it will last up to 10 to 15 years for this cost. Okay, now it is very popular battery storage option today right now, because it has very high efficiency and very high discharge time than the other batteries. Okay, but and control more than 90% of the global grid battery storage market. Okay, so it is extensively used. You can see here 90% of the battery energy storage power plants use lithium ion batteries. Now compared to the other battery options like nickel cadmium, then flow batteries and hydrogen fuel cells, etc., these lithium ion batteries have high energy density, okay, and are very lightweight than the other batteries. Also there are very high innovations are there. They are being induced for these lithium ion batteries, such as replacing the graphite with silicon, okay, which will increase the battery power capacity. Okay, and also they are making lithium ion batteries even more competitive for longer term storage, in case they are going to increase the 10 to 15 years life from 10 to 15 to more than 25 years. Okay, so there are very high amount of innovations are there, okay, which will replace the graphite with the silicon for better capacity. Also, lithium ion batteries are frequently used in developing countries for rural electrification. Okay, in case of villages in India, there are a lot of use of lithium ion batteries for, as we have seen, for inverter purpose also, and for other charging purposes. Now in case of rural areas or communities, lithium ion batteries are paired with solar panels to allow households and business to use limited amounts of electricity to charge cell phones. So when there is a scarcity of electricity, when there is not availability of electricity, in case of rural development, also with the help of National Solar Commission policy of India, the lithium batteries are installed in series with the solar panels, so that the solar panel will generate the electricity and the electricity will be stored in the ion batteries. Okay, that can be used for limited amount of purpose like charging the cell phones, appliances, etc. Now uh, also the different companies like Tesla Motors or General Electric also, Motors also, even BMW, Audi, etc. They have designed 1 megawatt lithium ion battery, okay, container that will be available for purchase in 2024. Okay, this will be easily transportable and will allow renewable energy facilities to have smaller, more flexible energy and storage options. So indeed they are going to make the battery more compact and more powerful in terms of storage. So this was about the lithium ion batteries. Now we are going to have a look on different other batteries, other storage power plants. Okay, so in the storage power plants, lithium ion batteries are connected in series and they have been uh, produced as a grid, and then we can take the power when there will be peak in the sorry there will be spike in the peak period. Next is lead acid battery. This is a second type of battery. Okay, this was also among the first battery technologies with the lithium ion, okay, used for energy storage. They are not very popular, okay, for grid storage because their low energy density. As we have seen here, this lithium ion battery has high energy density. That was because of that they were popular. But lead acid batteries, they have low energy density and it has shorter cycle, okay, shorter cycle of discharge and calendar life. Okay, so the life is also less. As we have seen, lithium ion batteries की life कितनी थी 10 से 15 साल, इसकी 4 से 5 साल होगी. Okay, so they were commonly used for electric cars but have recently been largely replaced with the lithium ion batteries. Okay, as there are different disadvantages of this lead acid battery like low or less calendar life, less discharge time, then less energy density. Okay, इसके लिए they have replaced lead acid battery in the electric vehicles with the longer lasting lithium ion batteries. If you can see any electric cars or electric vehicle, we can see there are lithium ion batteries only right now because of the advantages. Okay, next is flow batteries. Now this is a different kind of battery. Okay, so now these flow batteries are alternatives to the lithium ion batteries. Okay, इसका replacement है ये. Oh, but these are very less popular. Okay, rather than the lithium ion batteries. Flow batteries make up less than 5% of the battery market. Okay, in case here if you can see 90% of the battery market किसके पास है, lithium ion batteries के पास है. But flow batteries, even though it has a replacement to the lithium ion batteries, it has only 5% of market share, okay, in the battery market. So flow batteries have been used in multiple energy storage products that require longer energy storage durations. Okay, so flow batteries have low energy density, okay, like lead acid batteries, and have a long life cycles, but it has long life cycle which makes them suitable for supplying continuous power. Okay, there is a power plant in if you can see here in Washington state in US, that is called as Avista Utilities. Okay, they use flow battery storage because of the longer life and good capability, but it has low energy density. Now also if you can see 200 megawatt flow battery energy storage is currently being constructed in Dalian, China. Okay, so now this system will not only overtake the power reserve, okay, as the world biggest battery, but it will also be only the large scale battery that is made up of flow batteries instead of lithium ion batteries. So the world is going to what you called as choose the alternatives for the lead acid battery for the lithium ion batteries. Okay, the alternative is flow batteries. Next is solid state batteries. So there's this solid state batteries, it has multiple advantages over lithium ion batteries for large scale grid storage. Okay, so now here this lithium ion batteries can be used for, we have seen here, it also used for large scale battery storage at the electric vehicles. Okay, but this solid state batteries, this has advantages for storage of energy in large scale grid storage. Okay, now these solid state batteries, it consists of solid electrolytes which have higher energy densities. Okay, and they are also less prone to fires than liquid electrolytes. Okay, now here if you can see in lithium ion batteries, the electrolytes, okay, as we have seen are graphite. Okay, they are going to replace it with the silicon, but the electrolyte basically is made up of liquid in case of lithium ion batteries, which can result to different short circuit conditions which can easily turn into fire. So the alternative to reduce such things is solid state batteries, okay, which is having higher density, higher energy density, and are also much less prone to fires than the liquid electrolytes. Okay, in case of lithium ion batteries. Okay, now also the size of this solid state battery are smaller, okay, and highly safer. Okay, so this makes the solid state batteries well suited for large scale grid application. But as a disadvantage is that the cost of these solid state batteries is expensive than the lithium ion battery technology because it is very less developed. Developments कहाँ ज़्यादा है? In case of lithium ion batteries there are more developments because it is consisting of 90% of the market share. But now दिस सॉलिड स्टेट बैटरीज, इसके ऊपर इतना इनोवेशन और डेवलपमेंट नहीं हुआ, जिसके वजह से ओके फॉर बिकॉज ऑफ विच देर आर वेरी less technologies developed for these solid state batteries and they are very expensive in case of selling for the market share. Okay, this is like the EV sector right now. EV sector के अंदर क्या है, there are lot of competition right now but there are very less technologies, knowledge transfer बहुत कम है, इसलिए electric vehicles are not that popular right now. Okay, this has been similar example to the solid state batteries. इसके अंदर भी कॉस्ट ज़्यादा है क्योंकि डेवलपमेंट और डिज़ाइन उतना ज़्यादा नहीं है एज़ कम्पेयर टू लिथियम आयन बैटरीज. ओके, इसके बाद हाइड्रोजन. ओके, हाइड्रोजन फ्यूल सेल्स, वी कैन यूज़ such energy storage systems. Okay, in case if you have seen, if you have gone through the chemistry, okay, we have seen fuel cell. Fuel cell can be used as a alternative to different battery storage technology. Okay, in that fuel cells hydrogen gas is present and by the reactions we can generate the chemical energy into electrical energy. Okay, this is the principle of hydrogen that can be used as a fuel cell to generate electricity. Okay, so now in this case in hydrogen fuel cells electricity can be generated by combining hydrogen and oxygen. Okay, they are quite reliable and quiet. Okay, so operation unless the different power plants is quiet and reliable. Okay, sure दंगा वगैरह कुछ नहीं होता. Okay, it is reliable also with no moving parts. Okay, moving parts नहीं होने के वजह से there is no friction and the operation is quiet. Also it has a small footprint and high energy density. Also releases, it has release of no emissions. Okay, because hydrogen does not emit that much of carbon or the different emissions that can be hazardous for the air pollution. Okay, so when we are running on the pure hydrogen, that is the green hydrogen, the byproduct only is water. Okay, so emissions is also less. Now this process can be reversed, okay, making it useful for energy storage, which includes the electrolysis of water, produces oxygen and hydrogen. Okay, now here fuel cell which can use hydrogen as a fuel, okay, facilities can therefore produce hydrogen when electricity is cheap, and later use hydrogen to generate electricity when it is needed for electric generation. So at the off peak period we can generate the hydrogen from the fuel cell, and when there is a spike in the peak period we can generate electricity from that hydrogen. Okay, so bidirectional use hai iska. Hydrogen also be can also be produced by reforming biogas, ethanol or hydrocarbons. Okay, these are the different cheaper methods that emits carbon pollution. Okay, but fuel cell से जो hydrogen produce होगा it will only give byproduct as a water, but when we are using the reforming process for the generation of hydrogen by using biogas, ethanol or hydrocarbons, this can emit the carbon pollution. Okay, and last is flywheel. Okay, flywheel, okay, we can skip here, but if you are going to have a look on flywheel, is not suitable for long term energy storage. As I said earlier, it is a kind of capacitive plant. Okay, it can supply the generation or the grid for very less period of time. If you can see the table, flywheel के लिए maximum power rating is 20 megawatt only, but the discharge time is in seconds or minutes. Okay, life is very high, efficiency is high, okay, energy density is okay, moderate, but the discharge time is very less, so that it is not useful for long term purpose. Okay, long term energy storage, but are very effective for load leveling and load shifting applications. Suppose in a peak time, सपोज अगर एक बहुत ज़्यादा सर्ज आ गया इन केस ऑफ पीक विच इज़ नॉट supplyable by the different energy storage plants, at that time we can use flywheels to match the demand, so that the demand from the generation and the consumption will be equal. So in this case flywheels can be used. Okay, but there are also advantages of flywheels. Okay, it has a long life cycle, high energy density, low maintenance cost and quick response. Okay, जैसा start कर दिए वैसे it can produce the energy, so it has a quick response speeds. Okay, now motor which are storing the energy in flywheels, they are using, okay, they are up to 50,000 rpm, okay, which is of very high cost. Now this motor can later use that storage kinetic energy to generate electricity by going into reverse. Okay, this can also be a application of flywheel. Flywheels are commonly left in a vacuum so as to minimize air friction which could slow the wheel. Okay, so this is about the flywheel, okay, which is not used often but can be used to match the demand in the peak period. And lastly, storage and electric vehicles. Now this is the important point. Energy storage is especially important for electric vehicles. Okay, now electric vehicle right now has become more widespread, more popular. They will increase electricity demand at peak times. Okay, if you are going to charge your vehicle at the night time so that you can use it for the full day, you have to charge the vehicle at for 4 to 5 hours. Okay, even the fast charging is there, 3 to 4 hours charging is required for a vehicle, so it can increase the demand at the peak times. So now, as there is an example they have given, as professional come home from work and plug their cars for a nightly recharge, okay, at that time it can increase the demand at peak times. So now, to prevent the need for power plants to meet this extra demand of charging of electric vehicles, electricity hmm, electricity will need to be stored during off peak times. Okay, so storage is also important for households that generate their own renewable electricity. A car cannot be charged overnight by solar energy without a storage system. So इधर उन्होंने solution क्या दिया है, you can use their own renewable electricity. For example, you have to install your own solar power plant on the roof of your home, and then you have to use lithium ion batteries or different batteries to store the energy. And in order to reduce this demand, you have to charge your electric vehicle by the night, overnight, by using the solar energy with the storage system. Okay, so now without a storage system means you cannot be reliable on the energy storage power plants. You have to generate your own storage system. For example, the solar power plants, so the solar rooftops and your batteries to charge the electric vehicle. Now here electric vehicles can be used as backup storage during periods for grid failure or spikes in demand. Although most of the EVs today are not designed to supply energy back to the grid, now here there is a concept that is vehicle to grid. So grid to vehicle and vehicle to grid, there are two different concepts. In case of grid to vehicle, the grid will supply energy to the EV, and in case of vehicle to grid, the electric vehicle will supply the energy to the grid when there is peak demand. Okay, so these cars can store electricity in car batteries, and it can transfer the energy back into the grid later. So this technology is being emerging. Okay, right now it is not that popular, it is not even used extensive manner, इसका बहुत इस्तेमाल कम है, but there is an scope of using these EVs for supplying the grid when there is a very high demand in the peak. Okay, so this has been the different energy storage plants. Okay, starting from pumped storage power plant to flywheel we have seen, and electric vehicle we have also seen. So this was the last point of this chapter, and after this we are going to start the next chapter in the next week on Monday. Okay, also I have given the assignment. You have to submit the assignment before 21 of February. Okay, okay, so ठीक है, I'll stop the recording.